A missile leaves a warship off the coast. No pilot. No satellite holding its hand the whole way. And 90 minutes later, 1,000 miles inland, it flies through a specific window of a specific building. This is the Tomahawk cruise missile, and the engineering that makes that possible is stranger than you think. Start with how it even stays in the air. A Tomahawk is not really a rocket. It is a tiny jet aircraft. A tiny turbofan engine, wings that pop out after launch, and just enough fuel to cruise at around 500 miles an hour, low and flat, for over an hour. A booster fires it off the ship, falls away, the engine lights, and from then on it flies like a miniature unmanned plane. But flying is the easy part. The hard part is knowing where it is. For decades, the Tomahawk used a trick called terrain contour matching. Before the mission, planners load a 3D map of the ground along the route. As the missile flies, a radar altimeter reads the exact shape of the hills and valleys passing beneath it and compares that profile to the stored map. It is navigating by feeling the shape of the Earth. Closer to the target, a second system takes over. A camera in the nose compares what it sees to stored reference images of the target area, correcting its aim down to a few meters. GPS was added later, but the genius is that the missile can still find its target even if GPS is jammed, because it never fully depended on it. That is the real engineering achievement, not the explosion at the end. It is a machine that flies 1,000 miles at treetop height, reads the ground like a fingerprint, and arrives within a few meters of a target it has never seen, in a world actively trying to blind it. The warhead is almost an afterthought. Getting it there is the hard part. Subscribe and turn on the bell. We cut a new weapon open every week and show you what is inside.